Hello, my name is Gabriel Inchauste. I'm a systems engineer and I work at Development Gateway. Today I'm going to give you a quick tour of our automatic contract summarizer. First, some key concepts. This is a free tool that uses open source Python libraries and open source LLMs, and it has been registered as a digital public good. We wanted to create an affordable tool that could be used freely by developers without access to big cloud infrastructure. The purpose of this tool is to summarize government contracts and extract useful information in a standardized format. Once the information is extracted, it's much easier to import into a regular database for further analysis. We also wanted to provide a way to extend the functionality to summarize more languages and countries in the future. This tool operates in two phases. First, the training phase, where we teach the model what kind of information we want, and then a summarization phase, where we apply the model to new contracts. In the training phase, we provide pairs of contracts and the expected summary so the model can learn what to look for in the document and what kind of output we expect. Depending on the complexity and variety of contracts, we might need from a few dozen to around 100 examples. And this training phase is extremely important because it defines how accurate the tool will be when presented with new contracts. Training can take from minutes to days, depending on the hardware. In our case, it took less than 24 hours using an NVIDIA RTX 4080 with 16 GB of RAM. One of the initial goals was to create a tool that can run on consumer-grade hardware to lower the operational cost. However, it can run in the cloud too. For the training phase, first we selected the LLM. After testing many models, we chose Google's Flan T5 because it has a good balance between accuracy, memory footprint, speed, and it's also multi-language. Then we set up the tokenizer for this LLM, CUDA, and parameters that modify how the LLM will learn, like max chunk size, that's the maximum number of characters the LLM can process at once, and the number of training iterations or epoch. The bigger the epoch usually results in better accuracy, but it also takes longer. This part of the process was a lot of try and error, because there are not set rules that apply for training all models. As an example, we found out that chunks smaller than 500 were not big enough to capture meaningful data, and bigger than 8000 crashed the process. Also, too few training iterations result in low accuracy, but too many iterations only produce marginal improvements at the cost of many hours. To have a quick assessment of the accuracy, we checked an output variable called eval loss and stopped the training process when the value was smaller than 0.01. The training process has two parts. First, we run a script that downloads the LLM automatically, then learns how to transform dates that come in different formats into a standard date, month, year. For that, we created a document with hundreds of dates in a variety of formats and the translation to the day, month, year for each of these dates. The output of this training was saved as a new LLM that we use in the next steps. The second part used this pre-trained LLM to learn the summarization, and the process was similar. We instructed the model to read a contract and the summary we prepared manually, so it learns from a full contract what data look for and how to format the output data. This training took more than a day, and the result was a newly trained LLM that we will use from now on to summarize new contracts. This is the simple format defined for the summary. It uses pairs of key values that can be easily imported into a database or converted to JSON. Most of the contracts we used had tender information like contract name, IDs, dates, emails, etc. Others also had lists of goods and services like buy office supplies or build a road or fix something. And finally, some contracts also had award information. After training, we can start summarizing new contracts. We have scripts for processing single files or a whole directory. The tool supports Word and PDF formats. After processing each file, the tool generates a text file that follows the predefined format Processing one contract can take several seconds depending on the size of the document. Maybe more important than the code to train the LLM are a few essential supporting steps. One is the text extraction from Word and PDFs. This is a critical part of the pipeline because the AI doesn't see documents the way we do. We had to try and test multiple extraction approaches to reduce noise while preserving structure and context. Also, we decided to avoid non-open source libraries, which meant writing additional code to achieve the quality we needed with open source tools. Handling large documents was a challenge because our hardware could process only 2 pages at a time. To address this problem, we split the documents into smaller chunks, summarized each chunk independently, and then merged the results into a final cohesive summary. To prevent breaking sentences or losing context, we used an overlap strategy, carrying forward a portion of the previous chunk when processing the next one. Also, because not every chunk will contain all the data from the example file, we had to adapt the training strategy to match each chunk with the data present and do it automatically. Reducing hallucination was very important. We added a post-processing step that checks whether the generated data is grounded in the original contract text or not. In other words, the system verifies if the extracted facts can be traced back to the original content of the document. Now I will do a quick demo of the scripts that are part of the tool. We have scripts for training, summarization, and supporting functionality for pre and post processing.